So, these are the problems from Webwork, from our notes and stuff like that. So I want to go through these guys with you guys to make sure you understand this stuff. Because this alternating series, now you've got to pay very close attention to the directions on this stuff. If they just give you guys an alternating series and say, hey, does this thing converge or diverge? Well, it's a no-brainer. Use the alternating series test and declare victory once you've done the test. But if they go in there and go, here's an alternating series, is it absolute convergent, conditional convergent, or divergent, then you're going to have to actually go through the hierarchy thing that we were talking about before. So, and that's exactly what this direction is. They're giving you all these guys, all four of them are alternating series. So they're asking you, is it absolute convergent, conditional convergent, or does it diverge? Okay? So this first guy here. The sum is n goes from 1 to infinity of -1 to the n of 7n over 2n minus 1. The first thing you do, if you're going to do this hierarchy thing, is you check for absolute convergence. I always do the same thing every time, so I'm very consistent. So first thing we always do, if I'm given one of these questions, I'm going to check for absolute convergence, question mark. So I'm going to take my series and take the absolute value of it. And this is for your benefit, because when you take the absolute value of the series, what happens to the alternating part? It goes away. Negative absolute value of -1 to whatever power is going to go to be +1, and it goes away. So this part actually literally goes away, and for the absolute convergent, it turns into this guy. And it goes from 1 to infinity of 7n over 2n minus 1. Now, look at this series and tell what goes on. This is what you got to train yourself for. When I see this series, the sum is n goes from 1 to infinity of 7n over 2n minus 1, I look at the sequence part. And I notice that the sequence part, mentally, I see that the degree of the top equals the degree of the bottom. That sucker's not going down to 0. So I can use one of my other tests. And when that first test I came up with is kind of very helpful on quick answers. It's called the divergence test. So we happen to note that the limit as n approaches infinity of 7n over 2n minus 1 is equal to what? What's it equal to? Should we look at it and tell what it is? 7/2. But that's not 0. So therefore, by the divergence test, this thing diverges, which means it is not absolute convergent. Does that make sense? So this guy is not absolute convergent. So it has failed for absolute convergence. So I'm going to go for the next level. So I'm going to draw my little line here. I'm going to put the alternating back on there. So this is n goes from 1 to infinity of -1 to the n, 7n over 2n minus 1. And I'm going to check for conditional convergence. Basically, I'm putting the alternating back on there. I'm going to check the alternating series test. And if the alternating series test says this thing converges, we will call it conditional convergence. If it says it diverges, well, we just say it diverges and declare victory. So I got one more test to do, and that is the alternating series test. The Bn part, the part without the alternation, is the 7n over 2n minus 1. I'm going to check two things. Number one, I'm going to see if the terms go down. Plug n equals 1, n equals 2, n equals 3. When I plug in 1, 7 times 1 is 7. 2 times 1 is 2, minus 1 is 1. Plug in 2, I get 14 over 2 times 2 is 4, minus 1 is 3. When I plug in 3, I get 21 over 6 minus 1 is 5. I don't think my terms are going down at all. They look like they're actually getting a little bit bigger. But even more importantly, look at number 2. When I take the limit, we just did this a few seconds ago, of the Bn, the limit as n approaches infinity of the 7n divided by 2n minus 1, that's 7/2. That's not 0. This thing is divergent by the alternating series test. So the answer for this problem is it is divergent. It's not even conditional convergent. It failed that, didn't converge with the alternating series test. This guy is a divergent series. Okay? Let's try this guy next to it. So if I can block this thing off here so you guys can see these problems, because they kind of shoveled them all here at one time. Let's take a look at this guy. Here's a series. It's the sum as n goes from 1 to infinity of excuse me, sum as n goes from 1 to infinity of negative 1 to the n minus 1 divided by n to the 4th. Okay? Again, the directions is, so for this answer, it would have been D. Just make sure I answered the question there. D for, it was diverges. So this one, I'm going to check my hierarchy. I'm going to check for absolute convergence first. You always check for absolute convergence. If it fails that, then you check for conditional convergence. And if it fails that, it's divergent. So do it from a hierarchy. Absolute convergence, we take this series, and we take the absolute value of it. But you don't actually have to write all this stuff out, because we know that absolute value is going to kill off the negative 1 to the n stuff. So this becomes 1 over n to the 4th. I don't actually have to do a test on this dude. This guy's got a name. What's this guy's name? P series. P equals what? 4. And 4 is bigger than 1, which means this series does what? What is this P series going to do? I like a lot of interaction with you guys. Come on, talk to me. Okay. It converges. That's right. Which means, therefore, this series, the sum as n goes from 1 to infinity of negative 1 to the n minus 1 over n to the 4th, is absolute convergent. The answer for this one would be A. Does that make sense? Look at this guy down here. I got the sum as n goes from 1 to infinity of negative 1 to the n divided by n times the square root of n. Okay? So I'm going to clean this guy up. This is the sum as n goes from 1 to infinity of negative 1 to the n divided by, cleaning them up, n times the square root of n is n to the 3 halves. Okay. Also, I put the stuff on PowerPoint. I've uploaded it. Yeah, yeah. I did, but check your email, and you'll see there's a problem with it, so I had to fix it. But we'll talk about that later. Okay. The sum as n goes from 1 to infinity of negative 1 to the n divided by n to the 3 halves. N times the square root of n to the 3 halves. Well, again, I'm going to check for absolute convergence first. And for absolute convergence, we take the absolute value of this guy. And we know that absolute value of that negative 1 to the n goes away. So this is the sum as n goes from 1 to infinity of 1 over n to the 3 halves. What's this dude's name? It's got a name. I don't have to actually have to do a test on it. I should know these guys. What's this guy's name? Once again, this is a P series. What's P equal to? 3 halves, but 3 halves is bigger than 1, so this guy's going to do what? Converges. So guess what? This guy is absolute convergence. Absolute convergent. So the answer for this one, once again, is A. Because if the absolute value of it converges, the original alternating series is absolute convergent. Whether you had that condition negative 1 to the n was on it or not, this series is still going to converge. That's what absolute convergent means. And then the last one over here, I got the sum as n goes from 1 to infinity of negative 1 to the n minus 1. Again, checking my hierarchy, I'm going to check for absolute convergence first. So, big question mark there. It's the sum as n goes from 1 to infinity of the absolute value of negative 1 to the n minus 1 over n, which is the sum as n goes from 1 to infinity of 1 over n. Again, recognize it. This guy's got a name. What's his name? This one is the harmonic series. And what does the harmonic series do? It diverges, which means this guy is not absolute convergent. So then I go to the next level. We go back and take the series and put the negative 1 to the n minus 1 back on it, and we apply the alternating series test. The Bn part, the part without the alternation, is the 1 over n, and I got to check two things on alternating series. I got to make sure the terms go down and the limit goes to 0. So number 1, this thing starts at 1, so plug in n equals 1, n equals 2, n equals 3. 1 over 1 is 1. 1 over 2 is a half. 1 over 3 is a third. Yep, these terms are definitely going down. And number 2, when I take the limit as n approaches infinity of 1 over n, I get 1 over infinity, which is 0. So the terms go down and the thing goes to 0, which means by the alternating series test, it is convergent, right? Which means, therefore, the original series, the sum as n goes from 1 to infinity of the negative 1 n minus 1 over n, is what we say is conditional convergent. It's not absolute convergent, but it does converge. The condition is you've got to have that -1 to the n minus 1 on it. So this one answer, I think, called conditional convergent, we call it C. You're supposed to put C in on Webwork. Does that make sense? But notice, on every one of these problems, I did the same thing. If I'm checking for, again, it's in the directions. If the directions say, is it absolute convergent, conditional convergent, or does it diverge, you check for absolute convergence first. If it fails that, then you put the -1 to the whatever n minus 1 back on the problem, and then use the alternating series test. If it passes the alternating series test, it's called conditional convergent. And if it fails the alternating series test, that just pretty much throws it in your face, it diverges. So there's really two things you got to do to this thing. You first check for absolute convergence, and then if that works, great, it's absolute convergent. If it doesn't, if it fails that, then check for conditional convergence by doing the alternating series test on it. And what the results of the alternating series test tells you either conditional convergent or divergent. All right, again, Webwork, looking at these problems here. Says this, for problems 6 and 8, so I got 2 of them here for you. Consider the series. Attempt the ratio test to determine whether the series converges, and then you're supposed to answer. So given this thing right here, you're supposed to tell me what it equals to. And I'm going to give you a hint on this one, because this is Webwork. And then we're going to take the limit and tell what my limit of answer is. This will be my L number here. And then we're going to say, A, the ratio test, the series is absolute convergent. The series is divergent. The series is says it's converges conditionally. The ratio test is inconclusive, but this thing is absolute convergent by another test. The test is inconclusive, the series diverges by another test. The test is inconclusive, but the series is conditionally convergent by another test. Now, out of all these answers, I warned you about this. One of these answers is stupid. It's not a real answer. What does the ratio test tell you? It tells you one of 3 things. If L is less than 1, then the series is convergent. If it was an alternating series, it would be absolute convergent, right? 2, if L is greater than 1, what is the series then? Divergent. And 3, if L equals 1, the test is inconclusive, you should try another test. Where did the ratio test ever tell you that the series is conditionally convergent? It never does. It's either going to be absolutely convergent if it was an alternating series, or it's going to be divergent. So you see this answer C right here, the ratio test says the series is converges conditionally. That's just wrong, because that's not what the ratio test says. So you can automatically eliminate C from your choices, and C will never be an answer, because that's one of those red herring things we make up to see if you guys will chase it down. Okay, we do that on multiple choice tests. So here we go. This one is an alternating series, so let's see if it's going to be absolute convergent. It is I got a number raised to a power of n, so the ratio test is a good test on this guy. Powers of n and or factorials is when you want to use ratio test. So this guy's a 5 to the n in it, so we're going to definitely use the ratio test. So ratio test, we're going to take the limit as n approaches infinity of the absolute value of an plus 1 over an. This will be equal to the limit as n approaches infinity of the absolute value of an plus 1. In this problem, the an, the part without the alternation, is n to the 8th over 5 to the n. So when I plug in n plus 1, I get n plus 1 to the 8th divided by 5 to the n plus 1 divided by an, just recopy, n to the 8th divided by 5n. Does that make sense? Now I'm going to invert and multiply. So this is the limit as n approaches infinity of the absolute value of, this will be n plus 1 to the 8th divided by 5 to the n plus 1. I take by numerator fraction, kind of spread them apart, and then when I invert and multiply, I group together like terms. That 5 to the n on the bottom flips up and becomes 5 to the n on top, and that n to the 8th on the bottom would stay on the bottom, and I'm just grouping it together. Okay? Does that make sense? But clean it up. Remember, when we were playing with this ratio test, this is why you want to use ratio test on powers of n and or factorials, because they cancel out. Before I figure out the answer for this blank right here, I want to clean this up. How does this clean up? The powers of n are going to clean up. So the n to the fifth, excuse me, 5 to the n will stay there. 5 to the n plus 1, I'm going to clean that up and make it 5 times 5 to the n. I'm going to pull off one of my 5s. And so the 5 to the n's will cancel. Does that make sense? So you're left with this. The limit as n approaches infinity, absolute value of n plus 1 to the 8th divided by, just going to put that 5 up front, 5 n to the 8th. Does that make sense? Now, here's the deal. Do you see, because the absolute value on this thing, you'll notice that I dropped the negative 1 to the n plus 1 thing. I completely eliminated that. What does an absolute value do to a negative? It was there, but I just dropped him off because absolute value kills that off. And then once you do that, you can pretty much get rid of these absolute values. This is the answer. So I'm going to circle this right here. This is the answer we're going to plug into this blank right here. You would type into this first blank, parentheses, n plus 1 power 8, divide parentheses 5, n power 8, boom. That is the answer for the first blank. Now, you got to take the limit. Well, I can pull that 1/5 out front, and because they have an 8th power, I can factor out that 8th power and pull that limit on the inside. Limit is n approaches infinity of the n plus 1 over n raised to the 8th power. I just cleaned him up because remember, 8th power, you can factor out the power. Now the 5's out front here, and then put my limit on the inside. Now you guys tell me this. What's the limit as n approaches infinity of n plus 1 divided by n? Now the degree of the top equals degree of the bottom, so what's it going to be? This thing goes to what? 1, and what are you left with? To the 8th power, so you get 1 to the 8th, which is still 1, times 1/5 is 1/5. And this is your L value right here. And this 1/5 goes in this blank up here for when you're supposed to take your limit. The limit is 1/5. Now, tell me what you know. According to the ratio test, L less than 1, it's convergent, or an alternating series will be absolutely convergent. L is greater than 1, it diverges. L equals 1, the test is inconclusive. So my L, which is 1/5, is less than 1, which tells me this series is absolutely convergent. So the answer for this third part here, this is the first answer for the blank, this is the second answer for the blank, and the third one is ratio test, the thing is absolutely convergent. The answer is A for this particular problem. Does that make sense? Now, look at this guy over here. Another alternating series. It's the sum as n goes from 1 to infinity of negative 1 to the n times n divided by n squared plus 6. Okay? Got a question for you. Would you ever use a ratio test on this thing? Yes or no? No. Why? No. I'm just talking about ratio test. When do I use the ratio test? Two cases. There's no power of n and there's no factorials. I'd never use ratio test on it. Because guess what's happening when you use ratio test on this one? We're going to get L equals 1. It's going to be inconclusive. So I can let you know right now the test is going to be inconclusive. But they're making me do the ratio test on it to get these two answers up here. So let me show you. So if I was going to do the ratio test, which is what you're supposed to do on these problems, when I do the ratio test, yeah, I'm going to get 1 out of L, but here's the thing. The ratio test, you're going to take the limit as n approaches infinity, absolute value of an plus 1 over an. And remember, the negative 1 to the n stuff is going to cancel out with the absolute value, so I just kind of ignore that. The an part is really the rest of it, the n over n squared plus 6 in this case. So be careful on this one. An plus 1, the limit as n approaches infinity, is that absolute value of n plus 1 would be n plus 1 over n plus 1 squared plus 6. All I did was replace all my n's with n plus 1. Divided by an, which is n over n squared plus 6. Now, again, I used the absolute values to completely drop this guy off, so now I can drop the absolute value. This is the limit as n approaches infinity of n plus 1 divided by n plus 1 squared plus 6. And I'm kind of separating them and spreading them out. Invert and multiply. The n squared plus 6 shows up on top, and the n shows up on bottom. Does that make sense? This thing, there's nothing canceling on it, because I don't have powers of n or factorial, so ratio test is not really doing much for me here. So here's the thing. If you wanted to see it, I'll show it to you, but for this part, since nothing canceled, you can type this answer into that first blank, and Webwork will count it correctly for you. If you wanted to clean it up, I could. I could FOIL this top part out, so this is equal to the limit as n approaches infinity of the top part. N times n squared is n cubed. N times 6 is going to be plus 6n. 1 times n squared is n squared, and 1 times 6 is 6. I just FOILed the top part out. The bottom, I can clean this part up. N squared plus n plus 1 squared is n squared plus 2n plus 1 plus 6 makes it n squared plus 2n plus 7. Multiplying it times that n out front makes it n cubed plus 2n squared plus 7n. That's really, when I fold it out and distribute, this is what I got. And so there you can also put this answer into this case right here. But now, take your limit. What do you notice about the limit? And again, we don't want you guys to sit there and do L'Hopital rule 3 times, figure this thing out. We should look at it. Degree of the top is equal to degree of the bottom. And when degree of the top equals degree of the bottom, the answer is the ratio of leading coefficient when you take the limit as n approaches infinity. The leading coefficient is 1 over 1, so guess what this is? What a surprise. It's 1. So the answer for this second blank is my L equals 1, which means with L equals 1, the test is inconclusive, right? Can't tell what's going on. So what am I going to do? Well, I'm going to look at this thing and go, okay, let's see if this thing's going to be absolutely convergent. Absolutely convergent, I'm going to sit there and take the sum as n goes from 1 to infinity of the absolute value of this series, this negative 1 to the n over n squared plus 6. And the absolute value is going to kill off this guy, and that gives you the sum as n goes from 1 to infinity of n over n squared plus 6. Now, this is not the harmonic series, but here's what you guys should know. This is just a series, and all I'm going to do is I'm going to compare it, because it's not direct. It's not an actual p series or anything like that. 1 over n to the p is a p series. This guy is a polynomial over a polynomial, and I told you guys you're going to do a comparison test when you got polynomials over polynomials, and who are you going to compare to? Well, this I'm going to do a squiggly equal to. This is who I'm going to compare to. The sum as n goes from 1 to infinity of the commanders, n over n squared. N over n squared reduces to what? What's n over n squared? 1 over n. That guy's got a name. What's its name? Harmonic series. And what does the harmonic series do? Things we know. It diverges. So I'm going to do a limit comparison test on this guy. So when I take the limit as n approaches infinity, it would be the limit comparison test. Limit as n approaches infinity of the ratio of the unknown, which is the n over n squared plus 6 divided by the known, 1 over n. I'm going to invert and multiply. This is equal to the limit as n approaches infinity. Invert multiply, that'll be n squared over n squared plus 6. And again, degree of the top equals degree of the bottom. The answer is real leading coefficients. That's 1 over 1, which is 1. But now, this is my C value. And remember, with the limit comparison test, if I get a constant that's not 0 and not infinity, these two series are going to do the same thing. And what did this series do? Diverges. So this guy is going to diverge, which means this series, therefore, it's going to diverge. Therefore, the original series, which is the sum as n goes from 1 to infinity of this negative 1 to the n over n squared plus 6, is not absolutely convergent. So, it's not absolutely convergent. I got one more test. I'll give you one that you have to jump through some hoops on. So remember our hierarchy. If it's not absolutely convergent, I'm going to test for conditional convergence. Here's the series again. The sum as n goes from 1 to infinity of negative 1 to the n over n squared plus 6. How do I test for conditional convergence? I'm going to test the alternating series test. This is when you got to know these tests inside out. That's why I warned you guys about sheets of paper and flashcards and all that good stuff. It really does help. Alternating series test. The Bn part, the part without the alternation, is n over n squared plus 6. two things I'm going to test. I'm going to see if the terms go down. This series starts at 1, so n equals 1, n equals 2, n equals 3. Plugging in 1, it'll be 1 over 1 squared plus 6 is 7. Plugging in 2, I get 2 over 2 squared is 4 plus 6 is 10. Plugging in 3, I get 3 over 3 squared, which is 9, plus 6 is 15. And the numerators are going up, but the denominators are going up, getting bigger even more. So these terms are going down. That is, these fractions are going down. And number 2, when you take the limit as n approaches infinity of n over n squared plus 6, you'll notice the degree of the top is bigger than the degree of the bottom. And the bottom's bigger, your fact is you're going to get 0. Or, you know what? Great time to actually show somebody about L'Hopital rule. This will be the limit as n approaches infinity of 1 over 2n. When you plug in infinity, it's 1 over 2 times infinity is infinity, which is 0. So the terms go down, the thing goes to 0. What's it doing? Alternating series test says this thing's converging. So what do we rank this guy as? So therefore it would be what? Conditional convergent. So the answer to this problem is this. The ratio test was inconclusive, but by another test, it's conditional convergent. So up here, the ratio test is inconclusive, but it's conditional convergent by another test. The answer is F on this one. Does that make sense? Yeah, question.
So when you're doing the alternating series test,
yeah,
it fails the first test. If it's not going down, can you just scrap it there?
It's rarely going to fail the first. I mean, if you go up one term and then go back down, if it's basically you got to look over the big picture, and the terms have to go down. I have seen a few series that the first 1 or 2 terms go up and then they start going down, but they got to go down. Usually, most of them go down right from the beginning. The most important part about the alternating series test is that second part. That limit has got to go to 0. So if you got like the first term, the second term went up, it went down, up, and then down, 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 you're still good to go. The overall scheme they got to decrease and stuff like that. So that's why if you notice when I said this stuff, pay a real close attention. It's that second part that's the real killer. The limit's got to go to 0. Because if the first part doesn't go down, if it continues to go up or whatever, the limit won't go to 0, and then once again your clue is that second part's not going to go to 0. Okay. This one. It says this. Match each of the following series with the first correct statement. So once again, we know there's more than one answer to this stuff, so we got to go with the first correct statement. The first statement is the series is absolutely convergent by comparing it to a p-series. The second statement is the series is absolutely convergent by comparing it to a geometric series. The third statement says the series is absolutely convergent by using the ratio test. And the fourth series says it diverges. Okay. So this is really knowing your series. So we're going to do absolute convergence on these things. So we're going to be getting rid of that -1 to the n type thing here. So this first guy, I'm going to check for absolute convergence. And when I do that, you got the cosine of 8n. That's great. But remember, absolute convergence, you're going to be doing this. The sum as n goes from 1 to infinity of the absolute value of the cosine of 8n. So all those terms when cosine was negative are now actually positive, over n factorial. I had a question for you. This is my series, and it looks rather nasty here, but what test would you use on? Why? Big old factorial. Absolutely 100% correct. This is a ratio test problem. This is not a p-series. This is not a geometric series, so you're not going to compare to those guys. This is definitely ratio test. So I'm going to show you the ratio test. I'm going to sit there and take the limit as n approaches infinity of the absolute value of an plus 1 over an. This is your an part right in here. So this will be the limit as n approaches infinity of the absolute value of the cosine of 8 times n plus 1 over n plus 1 factorial divided by an, which is just this copy of this guy, the cosine of 8n over n factorial. And the trick that saves people lots of time on this stuff is invert multiplying and clean this stuff up. So this is equal to the limit as n approaches infinity of the cosine of 8 times n plus 1 divided by n plus 1 factorial. Notice what I do. I take my numerator fraction and spread them out. And then invert multiply, the n factorial shows up on top. The cosine of 8n shows up on bottom. Now here's my problem. How am I going to clean up this mess? I'm not. Factorials are, remember, ratio test. You know what's really going to clean up? Powers of n and factorials. Let's clean up that factorial. What is the definition of n factorial? It is n times n plus 1, excuse me, n minus 1. N times n minus 1 times n minus 2 all the way down to 1. What is n plus 1 factorial? Well, by definition, this is n plus 1 times n times n minus 1 times n minus 2 all the way down to 1. You'll notice your n's cancel, your n minus 1's cancel, n minus 2's cancel, the dots cancel, everybody cancels, but you're still left with one term left over, the n plus 1. I don't care about cosine. Now remember, cosine and sine, they're waves. They're going to bounce between what two numbers? Negative 1 and 1. Granted, it's absolute value, so they're really going to bounce between 0 and 1. So it's just some crappy fraction to bounce in between 0 and 1. So this is equal to the limit as n approaches infinity of this cosine of 8n plus 1 divided by the cosine of 8n times n plus 1. These are nothing but numbers bouncing between 0 and 1. Okay? Because it's cosine. And as n goes to, like I said, it goes to infinity, this thing just is going to continue to wave. Does that make sense? So they're nothing but, my point is, they're nothing but constants. So you got some crappy constant divided by some crappy constant, whatever n. But as n gets bigger and bigger and bigger, what's happening to the n plus 1 in the denominator? What's happening to my overall fraction? So you're getting some weird crappy number divided by infinity when you take the limit as n approaches infinity. Does that make sense? These are trig functions. They're just going to wave at you. But the n plus 1 goes to infinity. And when the denominator gets bigger, what's the overall fraction doing? Going to 0. So your L equals 0. And this is the ratio test. So in the ratio test, when L equals 0, L 0 is less than 1. So what's this series going to do? It's going to converge. And because this guy is cosine, and cosine does bounce between negative 1 and positive 1, we would say this is absolutely convergent. But we had to use the ratio test. The answer for this one is C. Does that make sense? And again, you're not supposed to think too deep about it. They're trying to throw you off by the cosine. What's the cosine going to do? Doesn't matter. It's going to bounce between. It doesn't blow off to infinity. And doesn't blow off to negative infinity. It just bounces between two numbers. It's that extra n plus 1 left over that really takes command and makes the thing go to 0. Does that make sense? Look at this dude here. Same idea. First off, what am I going to compare it to? Now, do you see any powers of n or factorials on this thing? No. So I'm not going to use the ratio test. Do you see numbers raised to powers of n only? That's geometric series. I don't see that either. So what I would be doing on this one would be comparing it to a p-series. So here's the thing you need to know. Now we're going to, again, I'm checking for absolute convergence. With absolute convergence, it's the sum as n goes from 1 to infinity of the absolute value of negative 1 to the n times the arctangent of n, trying to throw you off on that one, over n squared. Okay? The absolute value completely kills off that negative 1 to the n, so I'm ignoring that. Does that make sense? But here's the trick to this problem. I notice the arctangent. And I'm going to come over here and put a little down here. Put a little note. I happen to know that when I take my limit as n approaches infinity of the arctangent of n, do you know what the limit as n approaches infinity of arctangent of n, aka the arctangent of infinity actually is? It's one you're supposed to remember from Calculus 1, but very few people remember that kind of crap. What's the arctangent of infinity? pi. Good, yeah, it comes in. Pi over 2, half pi, 9 degrees. And it goes up to, because if you remember looking at the graph, and again, if you just think about the graph of the old y equals the arc tangent of x, it looks like this. At negative infinity, it goes negative pi halves. At positive infinity, it goes up to pi halves. But it converges, it's going towards pi halves. So this guy, arctangent of n, is actually less than or equal to pi halves. You can replace that with a constant, pi halves over n squared. But wait a minute, where do constants get to go, whether you have series or have integrals? Where are you going to put that constant? Out front. So this is pi halves times the sum as n goes from 1 to infinity of 1 over n squared. And that dude has a name. What's its name? P series, P equals, good, P series, P equals 2. What's it doing? That's bigger than 1, so it's going to converge. And in my comparison test, anything below converging. When the top converges, anybody below him is going to converge. Does that make sense? So therefore, it converges by the direct comparison test to a P series, which makes this thing, the answer is A on this one. Does that make sense? That's absolutely convergent, comparison it to a P series. This guy here. Again, they're throwing trig at you. And if it's not squared, trig, sines or cosines, bounces between -1 and 1. So you get some negative terms, you get some positive terms. So officially, by our definition, it's going to alternate. So we're going to check for absolute convergence on this thing. And it's the sum as n goes from 1 to infinity of the absolute value of the sine of 7n over 3n. Does that make sense? Okay? And so now, here we go. Sine bounces between -1 and 1. Absolute value of it is going to bounce between 0 and 1 because you can get rid of the negatives. So it bounces between 0 and 1 because it's got to be positive. So what's the biggest this thing ever going to get? What's the biggest sine ever gets? I don't care what the angle is. 1. So this is going to be less than or equal to the sum as n goes from 1 to infinity of 1 over 3 to the n. Does that make sense? And look at this series right here. This guy's got a name. What's its name? It's only got a number to a power of n. What do we call that? Numbers to powers of n. Geometric series. You got to know your series. This is a geometric series. Geometric series, the sum as n goes from 1 to infinity of a r to the n minus 1. Okay? And so I can rewrite this as the sum as n goes from 1 to infinity. 1 is the same thing to 1 to any power. So I can rewrite that with 1 and 1 to any power, same thing as 1. And I can factor out my n now. That'll be 1/3 to the n. And on this one, this is going to be the sum as n goes from 1 to infinity. To write him as my geometric series ar to the n minus 1, I can pull off one of my 1/3. You're left with 1/3 to the n minus 1. That tells me a is equal to 1/3, r equals 1/3. Absolute value of r is the absolute value of 1/3, which is 1/3. And remember your geometric series. The geometric series says if the absolute value of r is less than 1, it converges to a over 1 minus r, but it converges. And if the absolute value of r is greater than or equal to 1, the series diverges. That was my chapter 8.2 many moon ago. This is my geometric series. My r is 1/3, and 1/3 is less than 1. So what is this thing going to do? It's going to converge. Now, I don't care what it converges to because it's the guy on top. But since the guy on the top converges, what does that force the guy below him to have to do according to the direct comparison test? By the direct comparison test, this guy has got to converge. If the guy on the top converges, anybody below him converges. If the guy on the bottom diverges, the guy on the top diverges. That was the direct comparison test. So we compared it to a geometric series. So the answer is absolutely convergent. Comparing it to a geometric series, the answer for this one was B. Does that make sense? Did I lose you guys anywhere? Questions? So again, these are some interesting, great problems. But again, let me pull back the pages of time here for just a second. What's going to frustrate some students on these particular problems, and I just did a couple of them off of Webwork, 6 and 8, is plugging in the things into these blanks here. This right here is the L value. It's the second blank on this is a Webwork. You can even tell by the font that I copy paste this thing out of Webwork. This is the L value. But you got to clean up this answer, otherwise Webwork's not going to take it, because when we programmed Webwork, we did the cleanup version. And remember, when you're doing the ratio test, factorials and powers of n clean up and they're going to knock each other out. You know, 3 to the n on top and 3 to the n plus 1 on the bottom. You can pull off one of the 3's and the 3 to the n's cancel. Don't put 3 to the n in the thing, because Webwork's going to count that wrong. You got to clean it up, just like I did here with the 5 to the n's. You know, I'm left with a 5 on the bottom. Clean that up. The n to powers won't clean up, so you'll type in polynomials in this thing. That's why I kind of told you in this problem, this is what goes in that first blank. You know, the n to the 5 to the n and n 5 to the n plus 1 cancel, leaving you a 5 on the bottom. But the 8s don't, the n plus 1 to the 8th and n to the 8th do not cancel, so you just have to type that into this blank here. Factorials are going to cancel. This one, nothing cancels, so all I did was just clean them up by just kind of pulling out the polynomials. Okay, and so there's your clue on that one and stuff. Okay, yeah, question.
With the Webworks, where you have to say how or which one it does first, like which, I don't know what I'm trying to say, but like the previous 3 problems, it was like A, B, C, D.
Oh, wait a minute. Are you talking about the absolute convergent, conditional convergent, divergent problem? This one here? Well, you're talking about a problem like this where they ask you about absolute convergent, conditional convergent, or divergence. You're going to put the answer in there, A, C, D.
A question like, which one of these happens first?
Oh, which one of these happens first? All right, that was from chapter 8.3. Okay, sure. Good. Let's take a look at that.
No, I had a question about, is that going to be like on the test? Because then like we have to do a certain way of finding it instead of doing it the way
yes and no. Great answer, always like a politician here. Yes and no. The real answer is yes, but in a different way. We're not going to put it in a hierarchy, but I'm going to put it in multiple choice. On a multiple choice answer, there's only going to be one of those answers that actually work, and the other ones won't work. So let me show you an example of that. And I can actually do this by looking online here. So hold on just a second. Minimize this, minimize this. Let me go open a browser here, because I want to show you where these final exams are. I'm going to be posting some old final exams and some video solutions of those things. But if you go to math.uncc.edu, okay, and I go over here to undergraduate program information, but just go to the bottom over here, and you're going to see over here additional resources for students at the bottom under the undergraduate admission, course outlines and past common exams. Well, that's what you want, is that past common exam. So come over here to past common exams, course outlines. Let's see here. Did I click on the wrong one? I may have been. Course outlines. Hold on. Past common exams is what I want to see here. See calculus sequence. Oh yeah, we're in calculus 2. Maybe I should click on this one. Calc 2, sorry. And oh, that's just that. Hope they didn't take it down. It was up here just the other day. So 2000 up course material statistics courses.
I think you can just Google it, because I haven't done that before.
Well, we used to have it up here.
Well, like they don't bring you to the website for UNCC. I've never been able to find it using.
Well, literally, it was here the other day. This is embarrassing. Okay, Calc 2. This is the calculus sequence. Let's see, common exams, course outlines. That's not what I want. I want past common exams. Let's click on that one. Mark's up there changing the website. Sorry, he's got a new link to it. My fault. Okay, I didn't know he did that. Here it is. Did you see over here undergraduate program, and then they made a new bar over here? There it is. Past common exams. Calc 2. Do you feel lucky? Pick an exam. Pick a year. What year you want? How about 2014? My son was born. Let's go for that. All right. Now, look at the exam. And this is what you guys should be doing at this point right now. So I'm giving you guys a clue about how to help prepare, not just for test number 4, but also for the final exam. Half this final exam is going to be integrals. So I'm going to go through here, but I'm going to pull out question 4 to answer your question you're going to see. So here we go. What's the first question on the no calculator part? What does it ask you to do? Go ahead and tell me. What does it say? Integrate. Yeah. What's that one? Integrate. There's a sequence one. Do it. You got 10 seconds. Which of the following is true about the sequence AN equals n plus 1 over 3n plus 4? It's a sequence, not a series now. And they're asking you to take the limit. You got 1 second to tell me what the limit is. Yeah, 1/3 B. Yeah, you can look at it and know what the answer is. Congratulations, you made a 1 on the final exam. All right, so you got another integral right here. Integral. All right. There's a series right there. And look at how they worded it. This is what I was after. So even this is the no calculator section. Which of the following series is true about the sum as n goes from 0 to infinity of 3 divided by 2n? First off, what kind of series is this guy? What kind of series? Geometric. It's nothing but numbers and numbers raised to powers of n only. This is geometric. So with a geometric series, you can tell exactly what it converges to. Does it diverge? Does it diverge? Does it converge to 2, 3, or 6? You want to do this problem? Because they got one mess up on there. They started at 0. Okay? So you're going to have to, let me show you what you have to do. It's the beauty of doing this thing right here. So let me get myself a nice little clean sheet of paper here. Now I'm going to pull some more problems too. This is the sum, just copying it down. Sum as n goes from 0 to infinity of 3 over 2 to the n. Okay? And so pop it back up here. Make it full screen. All right. Our geometric series formula that I have memorized is sum as n goes from 1 to infinity of a r to the n minus 1. And remember, if the absolute value of r is less than 1, it converges to a over 1 minus r. If the absolute value of r is greater than or equal to 1, it diverges. Okay? Here was the deal. This thing starts at 0. We played algebra on these series. So I don't want to start at 0, I want to start at 1. So I'm going to add 1 to here. What was my pattern? If you add 1 to the summation, you got to do equal but opposite to inside the series. So wherever there's an n, I'm going to have to take away 1. Does that make sense? So this is now equal to the sum as n goes from 1 to infinity of 3 divided by 2 to the n minus 1. And remember, 3 goes out front. This will be 1 over 2 to the n minus 1, but you can raise 1 to any power and still get 1. So I'm going to put an n minus 1 on 1 power, 1 to any power is still 1. And so now I can rewrite this as the sum as n goes from 1 to infinity of 3 times 1/2 to the n minus 1. So a is equal to 3, r equals 1/2. Absolute value of r, absolute value of a half is a half, which is less than 1. So this thing converges to a over 1 minus r, which is a was 3 over 1 minus a half. Remember, no calculators, so don't screw up the math. 1 minus a half is what? A half. And when you divide by a half, you invert and multiply. So what's my answer? 6. This thing converges to 6. And I can go back over here to my final exam copy and say the answer is E. Okay? Now that was simple, but there's more. Wait. Okay, there's more of these guys. Area between curves type thing here. Hey, more integrals. And this integral is basic U substitution. This integral is integration by parts. This is an improper integral. This is a chapter 8 point Maclaurin series. That'll be chapter 8.7. I haven't gotten there yet. I'll get there next week. Or the week after. Here's one. Another series here. Let's read it. Consider the series. The sum as n goes from 1 to infinity of -1 to the n over n. Which of the following test results from a successful determination of the convergence or divergence of the series? Okay? There's only one answer that's correct on this guy. Okay? Would you use the integral test? Oh, you could, but see, it's alternating, which I really don't want to use an integral test on alternating. It's got to remember, you can't use an integral test on alternating because The integral test says the terms have to be positive, continuous, and decreasing as you look at a function. That negative one in makes it negative, so you can't use the integral test. Would you ever use the ratio test on this thing? Lord, no. There's no powers of n, there's no factorials. 1 to a power of n, we don't, negative 1 to the power of n, we don't count him. We're talking about an actual number, 3 to the n or something like that, and factorials is ratio test. So it's not going to be a ratio test, it's not going to be a ratio test. All right. Would you compare this guy? Well, number one, you only do comparison tests with positive terms. So this guy's got negative 1 to the n, no. So if I look at this guy legitimately, and they're talking about converging or diverging, what test am I going to use on it? It's an alternating series. So mindlessly, I should use the alternating series test, and you're absolutely correct. They didn't say anything about absolute converge or anything on that. They just said, hey, does this series converge or diverge? And by the alternating series test, this thing's going to converge. We've done this like 15 times already in class. The AN, the part without the alternation is, or the BN is 1 over n. The terms go down, the limit goes to 0. The answer is E to this problem. There's only going to be one answer right. The rest of them won't make sense. And yeah, I could use integral test and ratio test and stuff like that. Ratio test, you can have alternating series on a ratio test. It tells you when it's absolutely convergent and stuff. But I only use ratio test on powers of n and or factorials. And I don't have any of those in this problem. I'm never going to use ratio test. Okay. Oh, here's an integral table problem. And here's another, just basically, this is partial fraction problem because n squared minus 4 factors n plus 2 times n minus 2. So pretty much the answer is either be either D or E. So there you go. Suppose let's see. This one is basically you've got to integrate the derivative to get the original function back again. One of those. And this is that, which is the derivative. This is that fundamental theorem of calculus. Take derivative of the integral, chapter 5.4. The answer is going to be sine of 2t quantity squared plus 1 chain rule times derivative inside, which is 2. And you've got to figure out which one it's going to be. But wait, there's more. Here comes the second part of the test. You can use a calculator on this section. Here is find the arc length and which one of these formulas make up the arc length. So memorize your arc length. Finally, here's another series problem right here. Take a look at this dude. Consider the infinite series. The sum as n goes from 1 to infinity of 1 over n squared plus 1. Which of the following tests results in a successful determination of the convergence or divergence of this guy? First thing you should do on a problem like this is get the answer. You got a 50-50 shot. Is this thing going to converge or diverge? And this is what I was telling you guys about the mental comparison test. I'm not writing this crap out. I'm just going to tell you. This is sum as n goes from 1 to infinity of 1 over n squared plus 1. Whether I use I'm going to compare it to somebody. I clearly not going to use a ratio test. I could integrate it if you really wanted me to, but I can do a mental comparison test. 1 over n squared plus 1. I don't care about the constant. Limit comparison test. It may be directly compared. I don't know. But what I'm really going to compare this thing to is the sum of 1 over n squared. What's the sum of 1 over n squared? That's a p series. P equals what? 2, which means it does what? Converges. The answer is convergent. So I can automatically eliminate A and D. So I could do the integral test. It converges. Would I ever use the ratio test? No. And would I use comparing it to 1 over n, 2n? No. What did I actually compare it to? 1 over n squared. So out of all these answers, there's only one of them that actually fits the bill. Even though I didn't actually use the integral test, I could have. You see, this is a great example of what to answer your question of how we're going to word it on the test. And I'm going to do something very similar. There's only one right answer. There's more than one way to prove this thing, so I've got to guide you in the way I want you to prove it. The answer for this problem is B. I could have used the integral test on this one. I know it converges. Get that part down first. I can integrate it. I actually did a comparison test, but I surely didn't compare it to 1 over 2n, so don't pick that dude. Does that make sense? I've lost you anywhere. I mean, I'm trying to answer your question on terms of this. Does this make sense? Question?
Did you compare it to 1 over n squared?
Yes. That's because, and that's that mental comparison test. I didn't actually write it down for you guys because I haven't left the page, but who's in charge? The polynomial, the degree term. So it's 1 over n squared. That's not 1 over 2n. I compared it to 1 over n squared. Okay? Here's the interesting way of wording, finding the x-coordinate of the centroid. So it's 1 over the area times that, because you remember your densities cancel, so you guys got to get the right formula there. Here's another one. What's true about this series? which is following true about this series, A through E here. The sum is n goes from 1 to infinity of -1 to the n over 2n. First off, what kind of series is this, dude? Alternating series. Okay? It's an alternating series. So, and if I look at this thing, I can pull off the 2, and it's pretty much just 1 over n, alternating. And we know that converges by the alternating series test. So, we know it converges. So the answer A and B are gone. The answer can only be C, D, or E because we know it converges. The 2 doesn't matter, but if I did the alternating series test, your Bn is 1 over 2n if you want to do it that way. Plug n equals 1, n equals 2, n equals 3. The terms go down. And when I take my limit as n approaches infinity of 1 over 2n, I get 0, 1 over infinity, which is 0. This thing converges by the alternating series test. It converges. Now, the question is, does it converge to a positive number, a negative number, or 0? You know how you figure that out? That's why it's on the calculator section. Write out some terms. So here's how I would figure this part out. I'm going to write out my series. The sum as n goes from 1 to infinity of -1 to the n over 2n. We know by the alternating series test, I'm not going to write that up, it converges. So I'm going to come over here, blow this up, and here's my series right here. We know it converges by alternating series test. So what does it converge to? Let's find out. This series starts at 1. N equals 1. Then n equals 2. Then n equals 3. N equals 4. You don't have to do very many terms. When I plug n equals 1 in here, watch what happens. -1 to the first is -1. Over 2 times 1 is 2. Plus -1 squared is 1 over 2 times 2 is 4. -1 cubed is back to negative. 1 over 2 times 3 is 6. -1 to the fourth is plus. 1 over 2 times 4 is 8. I think I caught my pattern. And now, remember, this is under the calculator section. So if you want to see what's going on, and all you got to do is 3 or 4 terms, and you'll begin to get close to what the answer is going to be. So let's see what kind of answer. -1/2 plus 1/4 minus 1/6 plus 1/8. And notice I get -0.29166667. It's the sign of the first term, because that's still going to be the biggest term, and then they get smaller on these alternating series. So the sign of the first guy is really going to tell you what it goes to. But I just wanted to show you, what is it going towards? A negative number. So the answer to this problem is it's converging, and it's going to converge to a negative number. The answer is C. And a lot of people miss this one. It's kind of sad because all they had to do is just write out a few terms. I chose 4. And the first term will tell me what it goes to, because that's going to be the biggest term. Because remember, it's an alternating series, and if it converges, the terms have to get smaller. So whatever the big number is, and then it'll be plus or minus the next one, plus or minus. So you're kind of zeroing in pretty close to that first term. But just write out a few terms, and that even makes you more confident in terms of what it's going to go to. Does that make sense? So again, look at how a lot of these questions are worded. I don't just look at these problems. Here's a problem on. It looks like it's the trapezoid error-bound stuff here. So that's great. So make sure you go back and review that. Here's a table on integration and using the midpoint Riemann sum thing. Okay. Here is a problem of finding how much work, and they gave you a force function of x squared. You should integrate him from 1 to 10. All right, to get work. Average value of a function, 1 over b minus a times integral of the function. The reason why I want you guys to go over these old exams is because when you go over an old exam, have a separate sheet of paper right beside it and write down the formulas that you used on that exam, just to keep them in mind, because there's lots of stuff that's flipped out your ear by now. You got to go back and stick it back in. Okay, particle moving, area between volume rotation is what that one is. Oh, here's free response. Let's take a look at how bad this one is. All right, this one is a power series. That's chapter 8.7. We're getting there, not quite there yet. This one is an integral. Here's one. Find the interval of convergence of this particular power series. We just started this in chapter 8.5. To do an interval of convergence of the power series, check the endpoints. You're going to have to use the ratio test on this thing. and do it. I'll show you how to do this one on Tuesday, okay? Because we just started this, and I'll do this next time. And there we go. Does that make sense? So notice how many problems. Some tests have a lot more series problems than other tests. So you really want to make sure you go through multiple tests on this thing. But hopefully by showing you this thing, you know how I'm going to word on my test. I'm going to give you, you don't pick the first correct answer. I'm not going to do that to you. That's a classic Webwork thing. What I'm going to do is I'm going to give you a problem where there's only one right answer. And so the other ones, I could, and even though you didn't use that test, you got to think, could I have used that test? Like the integral test. Could I have used the integral test? Not on an alternating series. No, I couldn't have. You know, that type of thing. Does that make sense? You guys got other questions? Yeah, what you got?
So going through that one, if there weren't that many problems on work, is that pretty typical for the final exam?
Oh, well, that was just that semester. You know, it depends on the professors. Wait, hold on. Let me go over here. Let me do this. Hold on. Let me go back over here and scare you with another year. There's a year right there, 2016. Okay. The answer is, it's a crapshoot. You understand? We ask about 15 questions on the first part of the multiple choice, no calculator, about 13 questions on the second choice, and it alternates. Sometimes it's 13 on the first part, 15 on the second part. So around 28 to 30 questions on multiple choice. Bank on that. And then we got 5 questions on free response. And so every semester they change them up. Sometimes they'll put the work problems in the multiple choice part. Usually they'll put one on the free response. Let's take a look at this one. This one, integral. Yeah, by the way, if I haven't told you yet, make sure you know how to integrate before you keep walking on that exam. You got an integral area, integral, quadrant, integral. Here is a geometric series. You can figure out what it converges to. And I warned you about this one. Sometimes they don't write out the formula, they don't write out the summation. 0.4 plus 0.04 plus 0.004. In a geometric series, when they write it out, A is the first number. A is going to be 0.4. R is the number you multiply by one guy to get to the next guy. Well, I got to multiply by 1.4 to get to 0.04. What do I have to multiply by? 1/10. And then I got to multiply by 0.04 to get 0.004, 1/10. So your R is 1/10, your A is 0.4, and since R is 1/10, which is absolute value is less than 1, the answer is A over 1 minus R. A is 0.4 divided by parentheses 1 minus R, which is 1/10 of 0.1. The answer, when I put in my calculator, is 0.44444, or 4/10. The answer is C. And look at this one. They were messing you up. They didn't tell you the series. It's a series plus ... That's a clue. But it's a series, but it's 1 over 1 squared plus minus 1 over 2 squared plus 1 over 3 squared. What kind of series is this, dude? Can you actually write down the series? It is the sum. Well, first off, notice this. It's alternating. Positive, negative, positive, negative, positive. First term's positive. So this will be -1 to the n plus 1. That's going to make it positive starting on right foot. Times 1 over n squared. Each term is being squared, and is n is 1. You're squaring 1. N is 2. You're squaring 2. N is 3. You're squaring n. So it's 1 over n squared. Okay? And so now you know that fine fact and stuff like that, that it is an alternating series. And so you know it's, and with an alternating series, you can use the alternating series test. It's going to converge. Now you got to figure out what it's going to converge to. Now the hard part about this one, it was so trivial and people were confused on how to figure it out. Just add up the terms, okay? And you're going to figure out a range that this thing's going to add up to. And if you're really close to one of the numbers, add some more terms to it and then add it up. You'll zoom in on where the answer is going to be at. They're trying to get you guys to think outside the box on a problem like this. Does that make sense? All right, derivative. Oh, here's a power series of Maclaurin. Here is a power series, and you got to figure out the integral convergence. This is chapter 8.5. We're just getting there. I would have to do the ratio test on this one and test my endpoints and stuff. Look at the next part. This is a particle, time axis. How far does it travel? So arc length. No, this is velocity. Excuse me. Velocity. You want distance, so integrate it. Average velocity, 1 over b minus a times integral. Arc length. Taylor expansion. There's more power series stuff. Chapter 8.5. They love power series stuff on this one. 120-pound woman with a sandbag. You got to remember seeing this problem? Yeah, I put it on your exam. Okay. I changed the numbers a little bit because I made it metric, but whatever. Area between two curves. Oh, here's one right here. Here's a great one. Here are three series. And remember I told you about the mental comparison test. I can look at these things and tell, and you should too. Which of the following converges? Is it 1, 2, 3, all of them, the first two, the last one, whatever? Is this guy going to converge? What test would you do on this one if you actually wrote it out? Alternating series test. Your Bn is 1 over n plus 1. Okay? So this thing is going to converge. So because the terms go down and the fraction goes to 0. What about this dude right here? This is real important right here. Sum as n goes from 0 to infinity of 3n plus 5 divided by n plus 7. What's the deal? Right. So what are you using? What test is that? You notice that the limit, mental right there. I take the limit because the degree of the top is the degree of the bottom. Limit goes to 3. According to the divergence theorem, this thing's going to diverge. This one right here, I got the sum of n plus 100 divided by n cubed plus 1. Okay? I'm going to do a comparison test in my head. What would I compare it to? Pretty much this thing's going to be the same thing as what? The degree terms are your commander. N over n cubed, which makes it what? 1 over n squared, right? Because n divided by n cubed cleans up to be 1 over n squared. That's a p series. P equals 2, it converges. The answer is 1 and 3 is the answer. 1 and 3, the answer is A. You see what I'm getting at? I didn't actually write out the test. I did more of the mental test in my head, knowing what I know about tests. Partial fractions. Here's another summation right here. Consider the series. The sum as n goes from 1 to infinity of the natural log of n over n. Which of the following results in a successful determination of the series? All right, would you ever use a ratio test on this thing? Lord, no. There's no powers of n or factorials. Divergence test? No. If I take the limit as n approaches infinity, I get 0, so that's not the divergence test. Would you compare it to something other? Well, yeah, I would compare it, but not this dude, 1 over n squared. There's no n squared in this thing, and it is not going to clean up to be an n squared. Could you integrate it? Yeah, I would use u substitution. I would let u equal to the numerator, d as the denominator. So I would use the integral test on this. Even though I actually didn't use the integral test, the answer is D. Look at the answer E. We love to do this kind of crap at you guys. Would you use the alternating series test? Why not? It's not alternating. Yeah, don't use the alternating series test, but it's not alternating. So they throw these little red herrings, but you'd be amazed. I mean, oh, E, clearly. No, it's not alternating. So look for that. So here's another power series, and it's got a factorial in it, so you're going to use the ratio test on this, and the answer is going to be A, and I'll teach you that next time. But let's take a look about these areas. So here is the centroid problem. Here is area between, what are we going to do with this one? Calculate the rotation revolved around the y-axis type thing here. A hemispherical tank. I was waiting for this one. I just grabbed another one. Here it is, a hemispherical tank. And crappy, these people, they didn't even draw the hemispherical tank. But if it's going to be a hemispherical tank, it's going to be from the bottom because it's got to hold water. That doesn't really hold much water. Okay, so it'll be from the bottom. So, yeah, don't you kid yourself. It's going to be there, and the big point total, 10 points. There it is. So here's another Maclaurin series, and we're going to teach you guys about the Maclaurin series in chapter 8.7. We're not quite there yet. Midpoint rule, midpoint for trying to estimate an integral, and here's more of that stuff. So there's another one. So I just picked another one random. And that particular semester, they put it more in the multiple choice than the free response. Usually it's in the free response. Okay? Yes?
Did you say it's going to be the top of the sphere or the bottom of the sphere?
Usually when you have a hemispherical tank, it's going to be the bottom of the sphere. That's what holds the water and that type thing. See pictures from our notes in class. So that's that hemispherical tank. It kind of holds water at the bottom. So the hemisphere is from the bottom. You'll typically hold it like this on top. Usually it's going to be held at the bottom on the when you're using the tank to actually hold water. There's other tanks out there that we're going to use to, I don't know, if you go to the zoo or something like that, and they like to have the birds fly around something rather than they're going to create a structure. It'll be a hemispherical thing, and they'll close it in like that. But usually if it's a tank holding some kind of liquid, if it's hemispherical, it'll be the bottom part of the tank is the hemisphere. Okay. Hope this helped you guys out. And like I said, I recorded this thing today, so I'm going to post it for your friends. So, study hard on this thing, and I will see you guys on Tuesday.